Every day, millions of units of medication move through NHS hospitals in England. Capturing that physical inventory movement and translating it into a continuous data stream is the job of the Secondary Care Medicines Data Dataset, or SCMD. The SCMD is the definitive baseline for national health informatics. It tracks pharmacy stock control across all NHS acute, teaching, specialist, mental health, and community trusts. Downstream data analysts often assume datasets of this size are engineered as clean, static, append-only logs. They expect that once a month's records are written to the warehouse, those records are permanent. This diagram maps the ingestion pipeline from the NHS Trust Pharmacy to the analytics warehouse. It reveals two structural fractures hidden within the ingestion path that guarantee a standard append-only pipeline will fail. The first fracture is temporal. Historical records in the SCMD do not stay static. They undergo retroactive mutations months after their initial publication. The second fracture is structural. There is a documented, hard-coded schema drift scheduled for a future release that will break rigid data contracts. Building a robust pipeline for the SCMD means abandoning simple ingestion logic. We must architect for eventual consistency, strictly enforce clinical ontologies, and prepare for evolving data contracts before they deploy in production. The raw data originates in local NHS Trust pharmacy systems. An organization called RxInfo processes this stock control data and supplies it to the NHS Business Services Authority. This timeline illustrates the provisional release cadence. There is a strict 2-month delay between real-world events and publication. January's hospital activity is published in March. As provisional data flows into the open data portal, it is highly volatile, an incomplete snapshot subject to change. If your data pipeline treats these provisional files as an immutable source of truth, your analytics will slowly decouple from reality. To correct this volatility, the dataset undergoes a finalization phase. This occurs at the close of the financial year and is typically published in July. During this phase, RxInfo runs extensive backtracking adjustments. They correct errors, include delayed transactions, and retroactively alter the previously ingested provisional data to establish a validated annual baseline. The technical requirement here is absolute. Pipelines ingesting the SCMD must be built with an upsert or partition overwrite strategy. Here's the required overwrite logic. When the annual release drops, the data warehouse must completely drop and replace provisional partitions with validated, finalized data. Relying on an append-only strategy will duplicate millions of records and instantly corrupt downstream volume analysis. Engineering for this temporal lag ensures your analysts are running calculations on the definitive record, rather than ghost data that has already been backtracked out of existence. Resolving when the data arrives is only the first step. We also have to address the clinical ontology of what the data actually represents. NHS trusts use different internal stock systems. To force interoperability across this chaos, the SCMD standardizes all records using the Dictionary of Medicines and Devices, or DM+D. Specifically, the dataset identifies medicines at the Virtual Medicinal Product, or VMP level. The VMP describes the abstract, standardized concept of the medicine, like the active ingredient and dosage, entirely independent of its physical packaging or brand name. This diagram displays a sample row from the raw dataset, isolating the translation to the clinical ontology. The system translates a common item, like paracetamol 500 mg tablets, directly into its unique 15-digit SNOMED code, 421-096-11000001-109. This creates a severe datatyping trap. If you rely on automatic schema inference, generic ingestion parsers will look at that 15-digit code and immediately misinterpret it as a large integer or a float. That automatic typing triggers silent truncation and precision loss. The exact identifier is altered, permanently ruining your ability to join this table with other health records. The ingestion rule here is rigid. SNOMED codes must be explicitly cast and stored as string data types the moment they enter the staging layer. Respecting the clinical ontology at the point of ingestion protects the integrity of the primary key, keeping the dataset viable for complex analytical modeling downstream. The SCMD is actively evolving. NHS BSA has pre-announced specific dataset updates scheduled to deploy in the July 2026 provisional data release. Hard-coded pipelines that rely on strict column positioning or exact legacy naming conventions will break the moment this update is published. This animation compares the legacy architecture with the incoming July 2026 schema. First, unit of measure column names expand to include VMP prefixes. Second, 2 new columns are introduced capturing VMP unit dose metrics. Finally, SNOMED codes and unit identifiers officially become string data types, resolving the parsing risk. But there is a temporal complication in handling this schema drift. Because finalized data operates on a strict annual cycle, these new columns will only appear in the provisional releases starting in late 2026. The finalized dataset won't reflect these structural changes until the July 2027 update. For an entire transition year, your staging areas must gracefully handle mixed schemas across the provisional and finalized boundaries. Implementing proactive version-controlled data contracts now is the only way to prevent a total pipeline collapse when the structural ground shifts in 2026. The final and potentially most dangerous trap in the SCMD requires protecting users from the dataset's financial columns. The SCMD does not contain the actual net expenditure paid by hospitals to procure these medicines. This isolates the indicative cost column. The padlock represents the barrier to true financial data. These costs are strictly indicative, mathematically derived from public lists. True hospital prices are obscured by confidential access schemes. Analyzing this as actual spend drastically overestimates NHS expenditure. To prevent business users from making this error, data engineers must implement strict semantic layering within the presentation zone of the warehouse. By explicitly tagging these columns with metadata or appending suffixes like _indicative directly to the column headers, you bake the business logic right into the interface. This explicit semantic tagging guarantees analysts understand the constraints of the data, shielding the organization from reporting severe financial miscalculations. This diagram shows our completed, fortified architecture. By addressing the structural and temporal realities of the dataset, we've secured the ingestion path. We implemented partition overwrite logic to handle eventual consistency, ensuring retroactive backtracking adjustments are captured without data duplication. We enforced string casting to protect the SNOMED clinical ontology and deployed version schema contracts to survive the upcoming 2026 drift. And we wrapped the financial data in a semantic metadata layer, protecting the business logic of indicative costs from analytical misuse. Engineers who anticipate structural evolution and retroactive state changes align their technical infrastructure with the clinical reality of the source. This architecture provides the consistent record required for precise secondary care analytics.